Okay, I'm on page 8 of your packet, and I'm going to go over a specific type of sequence. It's called arithmetic. So this kind of looks like arithmetic, but we pronounce it arithmetic, okay? So we know that a sequence is an ordered list of numbers, so we went over that a couple of days ago, and we know the sum of the terms of a sequence is called a series. So we know what a sequence is, we know what a series is, and now we're going to go over what I mean by arithmetic. So while some sequences are simply random values, other sequences have a definite pattern. That is used to arrive at the sequence's terms. Two such sequences are, so we're going to go over two different types of sequences. One is arithmetic, and the other that we'll get to in a couple of days is called geometric. So now let's talk about the arithmetic sequence. When we see arithmetic sequence, I want you guys to think of adding. So the pattern is going to be about adding a fixed amount. So if a sequence of values follows a pattern of adding a fixed amount, from one term to the next, it is referred to as an arithmetic sequence. The number added to each term is constant. So the fixed amount is called the common difference. And the variable that we have for the common difference, we use the variable d, referring to the fact that the difference between two successive terms yields the constant value that was added. To find the common difference, subtract the first term from the second term. And here, if we're looking at an arithmetic sequence, here my x-axis is the term, or the subscript, so first term, second term, third term, fourth term, fifth term, sixth term, etc. And then, so the term location versus the actual term, we're going to have a linear relationship. So notice the linear nature of the scatter plot of the terms of an arithmetic sequence. All right, let's go to some examples. So these are all three types of an arithmetic sequence, and I know that it's an arithmetic sequence if it has a common difference. The common difference is what I'm adding or subtracting by each time. So here, 1 plus 3 gives me 4. 4 plus 3 gives me 7. 7 plus 3 gives me 10. 10 plus 3 gives me 13. 13 plus 3 gives me 16. So notice the linear nature that we have. Remember when we were looking at table of values and we saw if the y value, if we were adding or subtracting by the y values by the same amount, then it was going to be a linear function? Kind of the same idea here. So I know my common difference is 3. So I'm going to add 3 to each term. So now let's look at my next example. Here, going from 15 to 10, I'm going to subtract 5. 10 to 5, subtract 5. 5 to 0, subtract 5. 0 to negative 5, subtract 5. Negative 5 to negative 10, subtract 5. So d is equal to negative 5. So you could write this two different ways. I could either say add a negative 5 to each term, or I can just say subtract 5 to each term, or add negative 5. So subtracting 5 and adding a negative 5 is the same thing. Okay, and our third example, here I'm subtracting by 1/2. 1 to 1/2, and then 1/2 to 0, I subtract 1/2. 0 to negative 1/2, I subtract 1/2. So my common difference is negative 1/2. And I can either say I'm subtracting 1/2 to each term. Or I can say I'm adding a negative 1/2. So plus a negative 1/2 is the same thing as saying minus 1/2. Okay, let's turn the page over.
Students who have purchased a Bright Star Strong t-shirt, please pick them up in front of Ms. Bonilla's office.
Alright,
Thank you.
examples. Find the common difference for this arithmetic sequence. Okay, well, 5 plus 4, 9 plus 4, 13 plus 4. So the common difference is equal to 4. Find the common difference for the arithmetic sequence whose formula is blank. Okay, so they give me the formula here. Well, let me just calculate a couple terms and then I can figure out what the common difference is. So A1, the first term, means I'm plugging in 1 for n. So that means 6 times 1 plus 3. 6 plus 3 gives me 9. A2 would give me 6 times 2, plugging in 2 for n. So 6 times 3 is 12. 12 plus 3 is 15. And then A3 would give me 6 times 3 plus 3, that's 18, plus 3 gives me 21. So if I have my first 3 terms here now, I can find the common difference. How do I get from 9 to 15? I added 6. How do I get from 15 to 21? I added 6. So that means my common difference is equal to 6. Find the 10th term of the sequence. First, I need to figure out a formula. I have 2 formulas, okay? And I will give you guys these formulas on the test. So to find any term, I can use this formula. And S, that's when I'm dealing with the sum. So if the question has anything to do with the sum, I know to use this equation. If the question has nothing to do with the sum, then I use this equation. Okay, so I'm just going to put sum, no sum. So use this formula for everything else except the sum. So for number 3, I'm not talking about the sum at all. So I'm going to use this formula. AN is equal to A1 plus N minus 1 times D. So AN is equal to A1 plus N minus 1 times D. Okay, so I want the 10th term, so that means I'm plugging in 10 for N. Now, A1, I have my first term in the sequence. A1 is given to me. It's 3. So let's plug in. A10 is equal to, my A1 is 3, plus N is what? 10, because I'm finding the 10th term. Minus 1. And then D is my common difference. I need to figure out what the common difference is. Well, let's look at my list here. Going from 3 to 5, that's plus 2. Going from 5 to 7, plus 2. 7 to 9, plus 2. So that means my common difference has to be 2. Okay, so let's continue this on. At first, I'm going to do what's in the parentheses first. 10 minus 1 gives me 9. So this is going to be 3 plus 9 times 2. 9 times 2 is 18. And then 18 plus 3 is going to give me 21. All right, and the last example. Find A7 for an arithmetic sequence. I'm going to use this same formula because the question has nothing to do with the sum, so I use this one. So AN is equal to A1 plus N minus 1 times D. Let's see what I can plug in. I want the 7th. I want A7, so I'm plugging in A7. That means wherever I see an N here, I'm plugging in 7. A1 they give me. So instead of writing A1 here, A1 is 3x. So I'm going to write 3x. And they give me D. They say D is negative x. So I'm going to plug in negative x for D. So plus 7 minus 1 times a negative x. Put parentheses around this minus x, or this negative x, so it doesn't look like minus x. This negative x, the D, is being multiplied by that. Okay, so this is going to equal, I do parentheses first, 7 minus 1 gives me 6. So 3x plus 6 times a negative x This looks a little weird. I'm going to rewrite this. 3x, and this is going to be minus 6x. 6 times a negative x is negative 6x. You can write it like this. Or you could have written plus and negative. Doesn't matter. But 3x minus 6x gives me negative 3x. So A7 is equal to negative 3x.